$191 million. That's the most conservative estimate for the training cost of a single top-tier large language model like Google's Gemini Ultra. But if you think that number is just the cost of burning out a mountain of NVIDIA GPUs, you're missing the other 70% of the picture. We're not talking about server time. We're talking about the price of teaching a multi-billion parameter brain how to think. Today, we're doing a full financial autopsy on the AI race. I'm going to break down the 4 true pillars of LLM cost: the hidden data tax, the GPU obsession, the talent premium, and the secret usage fee. By the end of this, you'll know the economic truth behind the hype, whether you're just a developer or just a curious investor. Let's start with the one cost nobody talks about. Chapter 1, the data cost. Cleaning petabytes of web. Think of training an LLM like feeding a baby a library of books. The real cost isn't the paper or the ink, but hiring 1,000 editors to go through every single book first. They have to remove all the garbage, the duplicates, the conspiracy theories, and the low-quality social media posts. That cleanup crew, that's the data cost. The chinchilla scaling law tells us you need about 20 tokens of data for every one model parameter. For a 1 trillion parameter model, that's 20 trillion tokens of high-quality curated text. Companies spend fortunes on data licensing, paying for clean code bases, scientific papers, and high-quality proprietary information. But the biggest cost is the human labor. The engineers who build the massive data pipes, the annotators who perform the supervised fine-tuning, and the contractors who run the reinforcement learning from human feedback, or RLHF. This RLHF process is slow, expensive, and critical. It can easily cost millions just to make the AI safe and helpful. It's the ultimate quality control, and unlike a GPU, a human cannot be scaled on demand. Chapter 2, the hardware tax. NVIDIA, data centers, and power. If data is the brain's food, then the GPU is the engine. It's not just a powerful engine, it's an engine that runs non-stop at max power in a perfectly air-conditioned garage for months on end. The hardware cost is buying that engine, building that custom garage, and paying the shocking electricity bill. The primary currency here is the NVIDIA H100 GPU, a single unit of which sells for around $30,000. Training a frontier model requires thousands of them, connected by lightning fast, multi-$1,000 InfiniBand networking. The total cost is exponential. A massive cluster isn't just a rack of GPUs. It's a custom-built data center infrastructure designed to handle petawatts of power. Each H100 can pull up to 700 watts. Over a 4-month training run, the raw electricity and cooling alone for a massive cluster can run into the tens of millions of dollars. It's CapEx for the chips and OpEx for the power, all burning 24/7. Chapter 3, the talent premium, the $1,000,000 researcher. Who designed the machine and who taught the editors what to look for? The talent cost is the price of the master architect. Few hundred people on the planet who know how to design a multi-billion-dollar machine learning expert. They are the rarest minds in the world, and they command salaries that make a typical executive look cheap. Forget the average engineer salary. We're talking about the elite AI research scientists, those with PhDs and the published papers from DeepMind, OpenAI, and Google Brain. The base salaries for these top-tier LLM architects and engineers can easily start at $300,000, and with stock compensation, quickly surpass $2 million annually. Recruiting and retaining even a small team of 20 such individuals for a multi-year project can cost over $50 million just in compensation, rivaling the price of the GPU cluster itself. This is the non-fungible cost, the intellectual property and strategic insight that is necessary to even attempt a frontier model. And since you've made it this far, clearly you appreciate breaking down complex tech like this. Take 1 second, hit the like button, and subscribe so you don't miss the next analysis. It directly supports our deep dive research. Chapter 4, the hidden fee, inference and usage costs. You've trained the model, you've paid the architect. Now, every single time a user types a question, that model is running, and that costs money. The inference cost is like the invisible utility bill that ticks up every second, every day, for every user in the world who asks the AI a question. Training is a one-time massive cost. Inference is the persistent, recurring cost that can quickly dwarf the training bill over the model's lifespan. Inference is what happens when the model is in use, running the forward pass to generate a response. Even the most optimized models cost fractions of a cent per 1,000 tokens, but that scales to hundreds of thousands of dollars per day for models like GPT-4, which handle billions of daily user queries. This is why companies are obsessed with model efficiency, quantization, and sparsity. Every millisecond of delay and every token saved translates to millions of annual and operational savings. Inference is the cost that turns into a multi-billion-dollar business liability or asset. So the next time you see a headline about a $100 million LLM, remember, you're not just looking at a pile of hardware. You are seeing the convergence of a massive human-driven data curation effort, a catastrophic power bill, a handful of the world's most expensive researchers, and an astronomical ongoing usage fee. The The real price of an LLM is not just the cost of compute, but the cost of human-grade intelligence. But here's the twist. As models become more expensive to train, their APIs become cheaper to use. Is the entire AI ecosystem destined to become a handful of giant, closed-source monopolies? In the next video, we're going to look into the new AI law that is threatening to break up the tech giants and democratize model access. Click the video on the screen now to find out if the open source community can really win the AI war.